All right, now let's get into that coffee shop example. In developing your coffee shop's promotional media targeted to young professionals, you want to know whether you should feature lattes or cappuccino. Both drinks are popular in coffee shops, but you don't know which is more favored among young professionals. In a survey, you asked respondents how often they purchase each type of beverage. Here are the results for the 208 young professionals in your sample. So we have the latte results here and then cappuccino. Now, one thing to note here, let me put this here, is that there are no, whoops, there are no multiple groups here. This is repeated measures because, right, we got the same person reporting how many lattes they purchase and how many cappuccinos they purchase per week. And we have 208 of those pairings. So over here on the left, the lattes, we have our mean, so 2.26 versus 1.97, and then we have our standard deviation. And from the sample, we might say that lattes are purchased more often. But let's go back to our fundamental statistical question. We don't care what samples say, right? Right? Because they lie. Samples lie. So what we want to know is, does this difference in the sample means reflect sampling error? Or does the difference in the sample represent true differences in the population and how often young professionals purchase each of these beverages? And to answer that question, we will need the dependent samples t-test. And just like the independent samples t-test, we have assumptions and requirements. And they're really similar, but there are going to be crucial differences. So number one will be the same. We have to work with an interval or ratio type of variable. The dependent variable has to be that. And then number two, well, we already kind of described that, right? This is where it's going to be different. It's either going to have to be a repeated measures design or a paired samples design. And then number three and number four, on the surface, they look the same as the assumptions we need for the independent samples t-test, but there's a crucial difference here. So yes, we're looking at outliers, but we're looking at the differences between the paired observations. So we're going to take the difference between number of latte purchases and cappuccino purchases from the same person, and we're going to do that for all observations and see what the difference is. And from those differences, that's what we're going to look at. We're going to look for outliers in those differences. And for number four, we'll continue looking at the differences. So yes, we are going to look for normal distribution, but in this case, it's going to be the differences between the paired differences. And this requirement is less of a concern when sample sizes are large. For this class, we will proceed with analysis when the skewness of the differences is less than 2. All right, so back to our example. Notice here that we're saying that the average difference between the number of, so we're looking at the difference, right? So we're saying that the average difference between number of latte purchases and number of cappuccino purchases by young professionals is 0. The average of the differences, okay? And then alternatively, we're saying that it's not equal to 0. And for the degrees of freedom, where it's n minus 1, where n is the number of pairs of observations. So in our example here, we had 208 young professionals surveyed, and so our degrees of freedom would be 208 minus 1 equals 207. And as always, we have a 95% confidence level and alpha of 0.05. Now we have the formula for T for dependent samples, and it's actually a little more complicated than this, but this is the simplified version, but for our purposes it works. In the numerator, we have D bar, which stands for the average difference for each pair of observations. And then in the denominator, we have the standard deviation of the differences for each pair of observations divided by the square root of the sample size. So in our example's case, that's 208. And then the D bar would be the average of the 208 differences. And then this part right here, the SD is the standard deviation of the 208 differences. So here's a question for you. Let me type that here. What does it mean if just pretend there's a bar above that. So if D bar is small, so this part right here, the average difference for each pair of observations. Well, that would mean that the average difference, is small. Meaning people roughly purchase the same amount of both beverages. I was trying to figure out how to word that, but so yeah, that's what we're that's what that would mean when we see that. And so from performing this calculation, we get a value for T. And just like the independent samples t-test, we will reject the null hypothesis if the value is large, and then we will fail to reject the null hypothesis when it's small. All right, in the next video, let's continue with our analysis.